By the way, Sunday service.
Okay. Now, 39. The directions say, verify the given factors of the function f. How do you verify if something is a factor? How do you verify synthetic division by doing what? If your remainder is 0, then therefore it is a factor, meaning f at k is equal to 0, meaning there is no remainder, so therefore it's a factor. We good? Huh? We're not going to graph it, because I want you to prove to me algebraically that it's a factor. So the values that are factors are supposed to be x plus 2 and x minus 1, I believe. Is that correct? Okay, so that is going to be my lovely little factors. Notice that they don't have them in x equals k form. They have x minus k there, don't they? But what do I do synthetic division at? Do I do synthetic division at x minus k, or do I do synthetic division at k? At k, right? So I need to solve for x to find k, correct? Okay. So x plus 2 is equal to 0, so x is equal to negative 2. And x minus 1 is equal to 0, so x is equal to positive 1. You see I've boxed in both of those values? That says that x equals k, which k would imply that it is negative 2 and 1. You understand that?
First one is backwards what?
It's an x. It's an x. Be nice.
Where did you get that?
Nice. Yeah. Pretend it's an x. Now I need to use synthetic division at negative 2 and check it out also at 1. So I have 2 boxes there, don't I? I don't just have 1 box, I have 2 boxes that I have to synthetic division.
3-1.
Jet.
Hold on, where's the x plus 2 and x minus 1?
They were given in the textbook as part of the problem.
Oh.
We're good? Okay, so now I need to do synthetic division. Now I'm going to check for powers. 3, 2, 1, 0. Am I missing any powers?
So,
No. So I can add my coefficients there. So this is going to be 2, 1, negative 5, 2. And immediately draw my line, and I need to do my synthetic division. So I drop down my 2. 2 times negative 2 is negative 4. Gives me negative 3. Gives me a 6. Gives me a 1. Gives me a negative 2 to give me a 0. Oh, why is she doing that? Is 0 what I wanted? Yes. What does that mean? That it's a factor, and that I have to verify that it is a factor. Now, since I did synthetic division 1 time, what degree is this going to be? It was degree 3, so now it drops down to degree 2. Well, my question to you is, can I do synthetic division at the degree 2 line? Sure, why not? Because if 1 was a factor of the cubic function, it has to be a factor of the quadratic function. Do we understand that? So I'm going to do synthetic division using those 3 numbers up there, 2, negative 3, and 1. So I drop down the negative with a positive 2. 2 times 1 is 2, gives me negative 1. Negative 1 gives me a 0. Is 0 what I wanted? Yes. What does that imply? It's a factor set. Why would you want to use the regular one whenever it's already dropping it down a degree so that you know it's going to be much easier? Because, but you're going to have to do it like this because part B says to now find the remaining factors of f. How can I find the remaining factors of f? Did I do synthetic division on? Not once, but twice. Since I did synthetic division twice, this drops this thing down here from degree 2 down to a degree 1, which means this is part A. Now part B says to find the remaining factors. Well, what is this polynomial that I'm left with? 2x minus 1. That's a factor, just like it is up there. If you don't like it like that, could I solve this thing for x? If I solve this thing for x, I'd have 2x is equal to 1 to give me x is equal to 1/2. So that would mean it's x minus 1/2. You can have it either way. Whichever way your brain accepts it. Does that make sense? If 2x minus 1 is a factor, then that means 1/2 is a factor. They're the same exact thing. You don't have anything over here.
Oh, she was not.
Do you understand that?
We saw.
Do you understand what I just said?
I understand
Just different one.
Okay, do we understand letter B? Letter B says it's a factor. Whenever it asks for factor, it's what they gave us. These were factors, x plus 2 times x minus 1, which means 2x minus 1 or x minus 1/2 is your last factor. How many factors am I looking for? You're looking for as many factors as your highest exponent. What was my highest exponent? A 3. So since I'm looking for my highest exponent is 3, I'm looking for 3 factors. 2 were given, and my last one was x minus 1/2. Letter C. Letter C says, use your results to write the complete factorization of f. Now, what's my first factor that they gave me? X plus 2. So write it down. What's the second factor they gave me? Attached by multiplication. And what's the last factor that we found? X minus 1/2, because obviously Morgan likes it in that form rather than 2x minus 1. Would she have been wrong if she used 2x minus 1? No, she still would have been correct. Do we understand the factorization of it? Yes? Letter D. It says list all real zeros of f. Well, if this is the factorization of it, what are my zeros? That means solve each one of those for x. So x is equal to -2, 1, and 1/2. So you don't solve it. Do we get that? You don't do anything. You pick them right out of there. And
No,
yes,
if
Jeff, that was
you-
awesome.
If you would have left it as 2x minus 1, you would.
Then you'd have to solve that. Yes. If you would have left it as 2x minus 1, then you would have to solve it at that point. Which you would have got the same thing. Did we get that? Okay, did we get that? Now, letter E says to do what? Letter E says to then confirm your results by using a graph utility to graph the function. So what this means is it wants you to come over here and I want a new document, and I want a graph page, and I need to graph this. Can someone tell me what the problem was? Wow, thanks everyone for helping me out on that. David, can you say it loud, please?
Alright, 2x cubed plus x squared minus 5x.
Hold on. Plus 2x cubed plus.
X squared
Don't you slow, don't you fast.
minus 5x
Never happen.
plus 2.
I'm a woman, I've never had.
Oh my gosh, I just said the same thing, didn't I? I said it was this thing.
Okay, so there's my function. Now my question to you is I need to find out if my zeros that I calculated are correct. Now we can do this the long hard way by hitting menu, analyze, 0, and then doing left bound, right bound, but that sounds like a lot of work, and I'm kind of lazy. So since I already know what they are, right, I already know what they're -2, 1, and 1/2, can't I just check them by simply doing a trace? So hit menu, trace, and graph trace. What's the first one I want to type in? -2 looks great to me. Did I get 0? Shabang! There's a 0. And then 1 gives me another 0. And then 0.5 gives me my last 0. Did I confirm that my results are algebraically correct? Yes, I confirm them on the graphic calculator, but I'll have to do the menu, analyze 0, left bound, right bound, 9. Alright? Okay. Now, with that said, let's move on. I'll do one more like this, because I think there's a lot of stuff some of you are still not in left field. I want to make sure that we at least are in the infield. Okay, 41. Exactly the same problem, but this time they give me x minus 5 and x plus 4. That's man. Okay. Not too worried. Okay. Letter A. What's letter A say to do? Verify that those are factors. What does that mean?
Verify the factors.
Synthetic division. I need to do synthetic division at what?
5.
Not once, but how many times? Twice. Now, am I missing any powers? 4, 3, 2, 1, zilch. Am I missing any?
9.
No. So I'm going to write them down. 1, -4, -15, 58, and -40. Bring down the 1. 1 times 5 is 5. 1, 5, -10, -15, 8, positive 40. Give me a 0. Is that a factor?
Yes.
Yes. Now, what degree did this drop down to?
3.
It dropped down to degree 3. We all see that, yes or no? Notice how I always put that out there. Keeps us on track, doesn't it? Okay, now what do I need to do? I need to do synthetic division again. At -4, drop down to 1, -4 gives me -3, gives me 12, gives me 2, gives me a -8, gives me a 0. Is it a factor? Yes. Does that make sense? Okay, am I done on letter A? I sure am, but this is going to be what degree again?
2.
Degree 2. Now letter B says to do what? Letter B says find the remaining factors of F. Well, what polynomial am I left with? X squared minus 3x plus 2 is equal to 0. Why did I just set this thing equal to 0? Because whenever it says to find factors, factor is another synonym for zero, solution, x-intercepts, many others that I can't think of right now. Roots, did I say that one? No. Okay, so what should I do with this? I'm going to do binomials because that's the easiest method to use. So if I factor this into 2 binomials, I'm going to get an x and an x, a 1 and a 2, and a negative and a negative. What did it ask for? Did it ask for zeros or did it ask for roots? Sorry, did it ask for zeros or did it ask for factors? It asked for remaining factors. So what are my remaining factors? This, right? I don't have to solve them, do I? Because it asks for remaining factors. Yes or no? Do you understand the difference? Excellent. Now what's letter C? C as a cat.
Oh.
Use your results to write the complete factorization of F. So what was my first root that they gave me? My first factor? Well, if I have 5 being k, it has to be x minus 5. If I have k being -4, that has to be x plus 4. And then what else do I put down? Okay, is that the complete factorization? How do I know that I'm right? How do I check it? No. Yes, but not yet. What's my highest exponent on this problem? 4. So how many solutions should I look? How many factors should I be looking for? 4. Do I have 4 up there? Do I know that I'm right now without graphing it? Yes, so much easier. Saves me a lot of time. Letter D. Letter D says to do what? No. To find all the zeros. What's my 0 here? X is equal to 5, -4, 2, and 1. Do you see what I see? Way up on the board over there. It's a pretty factor. Yes? Then what does it say to do? It says to check it graphically, which we're not going to do right now. Because we know we're awesome at rock stars, right? Are we good? Okay. You have one more to do in that section. Go to the next section, and that is going to be problems 45 through 48. So problem 45 says use the rational zeros test to list all the possible rational zeros of F. First off, what's a rational number? Any number in the form of A? What? Any number in the form of a fraction is what a rational number is. So do you remember what I talked about on Friday? I talked about P over Q. And I said that our P over Q values reduces our beta from negative infinity to infinity all the way down to wherever our largest rational number was to our smallest rational number, right? So with the set, what does the P represent in this? It is your constant. So what is my constant? Do I care about the sign of it? No, I do not. So you can just put 3. What is my Q? Leading coefficient, which will be a 1. What are all the factors of 3? Plus or minus 1, plus or minus 3. What are all the factors of 1? Plus or minus 1. So now what we have to do is find a complete list of all of the lovely little P over Q values. So what is 1 divided by 1? 1. What is 3 divided by 1? 3. Now what you need to understand is I'm being very nice. I'm not making you put plus or minus in front of every one of those numbers. If you put a plus or minus at the beginning, I'm cool with it. But your brain needs to make sure that you understand that that plus or minus goes to every single term that you have there. Now my question to you is, what is my largest number? My largest possible factor? What is my smallest possible factor? Now, nope, negative 3. So my window size is going to be what, folks, on my graphic calculator? Why do I want to go from negative 4 to positive 4? So I can see my value at 3 and at negative 3. If I put it at 3 and at negative 3, sometimes the calculator, depending on the model that you're using, will cut off that value. So we always want to go over it, okay? Now, what this means is I want to graph this thing just to show you something. So I'm going to get Control Doc, add a graphs page, and this is problem number 45. So that's going to be x caret 3 plus 3x squared minus x minus 3. And I'm going to hit graph, and then I'm going to immediately not look at it. I'm going to go straight to window and window settings. And I'm going to change my settings to be from negative 4 to 4. And then I'm going to go by units of 1 on my x scale. Why am I going by units of 1? Because our brains think really well on the scale of 1, correct? Anything else? We kind of mess around with it a little bit. This is what we have. This tells me a lot, doesn't it? This function that I'm looking at is a cubic function, is it not? Which means I'm supposed to have how many zeros? 3. Which means if they are outside of the values negative 3 to 3, then that means my numbers are either irrational, right, or imaginary. So what can I conclude about this right now? That I have a 0 at negative 3, negative 1, and 1. They're all rational zeros. Is that not helpful for us? Do you have to graph this on this part of the problem? No. All you have to do is in your list would be over 2. Do we get that? Yes or no? Oh, because you put it all in the exponent. Huh. Okay, 49. Go to the next set of instructions. This is find all the real solutions of the polynomial equation. Real. What's a real number? Remember, Mama gave birth to a set of twins. A set of twins is going to be the irrational and the rational number system. The rational number system is the nice number system that everybody likes, and then we have the irrational number system, which was the mean one, right? Black sheep of the family, no one liked it. Okay? Now, if we are not a member of the real number system, then what number are you? What number system are you a member of? Imaginary. Do we like imaginary numbers? Well, not really. But you tell me, can we see them on our XY plane? Can we see imaginary roots on our XY plane? No, we can't see them. Which means the only way we can get to them is by using the quadratic formula. Correct? I love this stuff. It's so much fun. Now, what are we going to do here? There's 2 or 3 different ways you can do this. When in doubt, what should you do? Graph it, right? When in doubt, graph it. Completely legit here. For me, what you guys are going to be doing tomorrow, you're going to be doing P over Q values a lot. Because P over Q gives me a window size. If my P value is 4, my Q value is 1, give me plus or minus 1, 2, and 4. Which tells me my window is going to be from negative 5 to 5. Well, this is extremely important because if I graph this function, someone read that problem to me. x caret to the fourth minus
X
zero.
over
x caret to the 3.
minus 2x minus.
If I graph this thing, this is what I get. Do I care about that? No, I'm going to go straight to my menu, window settings, -5, 5, 1, and hit OK. Now, why do I care about this? This gives me a lot of information, doesn't it? It's x to the fourth, which means it has to look like x squared, which means both of them are rising according to the leading coefficient test. A lot of information there, right? Now, this tells me that I can see two unique places where it crosses the x-axis. If it crosses the x-axis at two unique places, what can you conclude about the other two remaining factors? Nope, a double root means it touches the graph and then goes right back up in the direction, the opposite direction, right? So it's not a double root. Why are they imagining that? Because they're not there. Very simple. They're imaginary because they're not there. Okay? Which tells me if I do synthetic division at those two roots that you see up there, and I get a quadratic, it's going to come out to being an imaginary number. Do you understand that? Now I'm going to show you this because what value do I get to be a root over here? Menu, trace, graph trace. Sure does look like -1 to me. Is it -1? -1 comma 0. Yep. What's another one over there? 2. Hit 2 and hit enter. Yep, that gives me another 0. So if I come back over here and do synthetic division at -1
Wait to do all this.
and at 2. No, I'm showing you something from the point. I'm showing you
What
something
would
from
be
the
the
point.
answer to the
We write this
We're getting there. We're getting there.
We write this down.
It will never hurt you not to write it down. Now will it?
Yeah, but it'll get confusing once we're on the homework, don't know what happened.
No, because it'll be like, huh, why did she do that? Okay, 1, -1, 0, -2, -4. 4, 3, 2, 0, 1, we're good to go. So I start doing synthetic division. 1, -1, -2, 2, 2, 2, 0. Oh, I messed up. I did. Did I make the sign up there?
They, yeah,
Your
negative
your
1.
second page will be negative.
Yeah. The one below
Right above the
it.
0. Should be a negative 2. Over.
No, down.
Yeah.
Ah, yes. Right there. Thanks. So give me a 0. Yes? We see that? So we know that's a factor. And we also know that this is down to degree what?
Right.
So we do it again. 2, 0, 0, 2, 4, 0. This drops it down to degree 2. That's helpful because now, look at it. That's going to be x squared plus 2 is equal to 0. Can I factor that into two binomials? I cannot, but can I take that over to the other side? I can take this x over. I mean that 2 over. And I get -2. I can take the square root. X equals plus or minus the square root of -2. What's the square root of -2 equivalent to?
Right.
I square root of 2. Now, today you don't have to go this far. What your brain needs to understand is whenever you do synthetic division, if you get this far and you know you can't solve it, you're done. If you understand from the beginning, that it's going to have imaginary roots, do I have to do synthetic division? No. If your brain grasps this and know that the only real roots are going to be -1 and 2, then you're done. Right? You're done. Because it's asked for all the real roots. The other two remaining roots have to be what? Imaginary. I can get all of this information from my graph. Do we get that, yes or no? If you can't get all the information from the graph, then you are forced to do synthetic division to make sure that you're correct. Do we understand that? Okay, the next section For 53 through 55, it says use the zero root feature for graph utility to approximate the 3 decimal places, the zeros of the function. Turn one of the exact zeros and use synthetic division to verify your results. So what it's saying to do is to find all the zeros that are decimals, but then to find a rational one and do synthetic division to prove that you're right. Okay, I'm not worried about that one right now. I want to move on to problem 57. 57 through 60, it says, use Descartes' rule of signs to determine the number, possible numbers of positive and negative real roots. Okay. Well, remember on Friday we talked about the n. You counted the number of sign changes at f of x and then f at negative x. We talked about that. So what we have to do is we have to find positive roots here. So I need to take my f of x, and I need to count sign changes. A positive to a negative, is that a sign change? Yes. How about a negative to a positive? Yes. How about a positive to a negative? Yes. How about a negative to a positive? Yes. Do we see that I changed my signs from a positive to a negative, vice versa, 4 times? So this means n is equal to 4. That's the number of sign changes that I have. So my positive roots are going to be 4 or n minus 2, which is going to be 4 minus 2, which gives you 2. Right? And then 2 minus 2, which gives you 0. And can I do that again? Or will it give me a negative outcome? Can I take 0 minus 2? No. So I'm going to have 4, 2, or 0 possible positive roots. I'm going to have 4, 2, or 0 possible positive roots. I take this number, then I subtract 2 from it, gives me this, and I subtract 2 from it again, and it's going to give me the 0.
Why do you subtract 2?
Because that's the formula. It's always n minus 2. Okay, that's my positive roots. Now, to do my negative roots. Negative roots says I need to do f at negative x. But what happens when you do f at negative x? The signs change for which powers? For the even powers or for the odd powers? They only change for the odd powers. All the even powers stay exactly the same. Why? Because a negative times a negative is a positive. So does it affect the quantity? No. So I have an even power, so it stays 2x to the 4th. I have an odd power, so instead of minus x cubed, I'm going to have plus x cubed. I have an even power, which is x squared, so I keep it. I have an odd power, so it changes to plus, and then the constant comes down. So now I need to count the number of sign changes in here. Well, did I actually have any sign changes ever? No, I didn't, which tells me n is equal to 0. That gives me a lot of information. Because, folks, what's my highest exponent here? 4. My highest exponent is 4. Now, this is the beautiful thing about it. I have positive, I have negative, and I have imaginary roots, and then I have a total. My total has to be 4 every time. I have to have 4 roots every time, don't I? Do we see that? Well, what if I have 4 positive roots? Well, how many are left to be negative? Can't have any negative, and I can't have any imaginary. Because I have to have a grand total of 4 every time, right? What if I have 2 positive roots?
You need a negative and imaginary.
Then I have 0 negative still. Because why is it 0 still? Because it has to be. And then how many are left to be imaginary? 2. If I have 0 positive and 0 negative, how many are left to be imaginary? 4. Do we understand this? Okay? That's what you guys need to do for homework. Then 61 through 65, read the directions. You guys should know exactly what you're doing. Tomorrow when you come in here, I will be answering any questions you have over the homework after I've seen that you've attempted it. And then you guys will have a worksheet in class, working in groups. Yes.
What is the homework again?
The answer is going to be this lovely little Oh, man. It's gonna be this. That chart is the answer to 57. 39 through 65 odds.
Yeah, that's not either.
I have to collect it, you can't send it.
Well,
Well, you can, but it's not.
I saved.
They don't have to be taxes. You already have right. I gotta get this from your calculator. You can look at my answer key here.